Good afternoon, students. Let me explain some more questions on differentiation. Let us see the question of inverse trigonometrical function, that is very much important topic of differentiation. Now the question is differentiate y equal to tan inverse under root 1 plus sin x upon 1 minus sin x. Now in this question our main aim is to make the same angle here inside and outside. Now here we are having tan inverse, so therefore here must be the function of tan. It means we have to convert this whole function into tan. Now let us see how to start the question. Now y can be written as y equal to tan inverse under root 1 plus sin x. Sin x can be written as cos pi by 2 minus x. Similarly, in the denominator, this sin x again can be written as cos pi by 2 minus x. So, we can easily use the result of 1 plus cos theta and 1 minus cos theta. Again, we know 1 plus cos theta is 2 cos square theta by 2. It means 2 cos square pi by 4 minus x by 2. Similarly, in the denominator, 1 minus cos theta is again 2 sin square theta by 2. Here our theta is pi by 2 minus x. So it becomes 2 sin square pi by 4 minus x by 2. Now simplifying it, we are getting here, and by taking the square root, we are getting cos by sin is what? Cot. So it can be written as tan inverse cot pi by 4 minus x by 2. Now we want to have the same angle here and there. So we can easily convert cot into tan by using what? Cot theta can be written as tan 90 minus theta. Then using this result we can write it here. It can be written as tan pi by 2 minus pi by 4 minus x by 2. Again simplifying it, tan inverse by simplifying the whole bracket. We are getting it here pi by 2 minus pi by 4 is pi by 2 plus x by 2. Now we are having the same t ratios here and here. So it can be written as y equal to pi by 4 plus x by 2. Then we have to find out its derivative. So its derivative dy by dx. The derivative of constant term is 0 plus the derivative of x by 2 is 1 by 2. So the differentiation of this is equal to dy by dx equal to 1 by 2. See this point, that is very much important point here. Either we can convert it by making it a complete square, or easily we can convert them by changing this sign here into cos by using the complementary angle. This sin x can be written as cos pi by 2 minus x. Similarly, in the denominator, sin x can be written as cos pi by 2 minus x. Then using the result of 1 plus cos theta and 1 minus cos theta, simplifying it, now again we are getting here cot, then converting it into tan, simplifying, so our y becomes pi by 4 plus x by 2. Therefore, dy by dx equal to 1 by 2. Now let us see another question. We have to differentiate cos inverse 2 cos x plus 3 sin x upon under root 13. Let us see how to do the question. Now therefore y equal to cos inverse, by separating it here, it can be written as 2 by under root 3 into cos x plus 3 upon under root 13 sin x. Now again let us see, this point is very much important point. The square of this plus the square of this coefficient is equal to 1. The square of the coefficient of cos x and the coefficient of sin x, when we are doing it, this is equal to 1. So we can say here, we can take, let it be what? Cos theta 2 by under root 13. If the cos theta is 2 by under root 13, then the sin theta is what? 3 by under root 13. Using this result, sin square theta plus cos square theta equal to 1. This will give us the value of what? Sin theta. Now putting this here, we are getting here y equal to cos inverse. Now this is what? Cos theta into cos x plus sin theta into sin x. Now using cos A plus cos A cos B plus sin A sin B. We know cos A cos B plus sin A sin B is what? Cos A minus B. It can be written as cos x minus theta. Then again simplifying, y is equal to x minus theta. Resubstituting the value of theta here, so it is equal to y equal to x minus cos inverse 2 by under root 30. Again, now this is equal to y. Now dy by dx, the derivative of x is 1. Now this is the constant term, and the derivative of constant term is always 0. So therefore dy by dx equal to 1 minus 0 equal to 1. Now here see one of the important question, and it's very much easy. We have to y is given equal to secant inverse x plus 1 upon x minus 1 plus sine inverse x minus 1 upon x plus 1. Now see the very much important point here. Again y can be written as y equal to, because secant inverse x equal to cos inverse 1 upon x. So this secant inverse x plus 1 upon x minus 1 can be written as cos inverse x minus 1 upon x plus 1. This we have done in what? Inverse trigonometrical function. So it can be written as cos inverse x minus 1 upon x plus 1 plus sine inverse x minus 1 upon x plus 1. Now in inverse trigonometry we have learned the result. Cos inverse theta plus sine inverse theta is equal to what? Pi by 2. Now theta is same here. So this can be written as, again using cos inverse theta plus sine inverse theta is equal to pi by 2. Now y is equal to pi by 2. Therefore dy by dx equal to 0, because pi by 2 is a constant term. This is the one of the important question. Directly we have used the result and we have differentiated it. This can be asked in 1 marks question. Now here see the differentiation of logarithmic function. Differentiate y equal to log of 3 with the base x. Now let us see how to do the question. Now here we have to use the laws of logarithm. We have written here log of a with the base b is equal to log of a upon log of b. This is known as base changing formula. See it again, log of a with the base b is equal to log of a upon log of b. Using this result here, y can be written as log of 3 upon log of x. Now log of 3 is the constant quantity, we can keep it as it is, and log of x can be written as log of x raised to power minus 1. Now differentiating it, dy by dx, again log of 3 as it is. Now we have to differentiate log x whole power minus 1. Then again this minus power will be here, log of x minus 1 minus 1, using the derivative of x raised to power n equal to nx raised to power n minus 1. We have used this result, so this power is here, log of x minus 1 minus 1 into derivative of log x. Now again simplifying, this is what? Minus log 3 upon log of x whole square. Again the derivative of log x is what? 1 upon x. See it again. Just see the starting, we have to differentiate y equal to log of 3 with the base x. Now first we can write it, y can be written as log of 3 upon log of x. Constant quantity will remain as it is. We will differentiate the remaining function. It can be written as log of x whole power minus 1. Then we can differentiate it and getting our answer. Now again see the similar question. Now differentiate log of x with the base 5, and there again the base is what? 5. Now see this question here. Now it y is equal to this. So here it can be written as, again by using here we know the derivative of log x is 1 upon x. But the derivative of log x with the base a is equal to 1 upon x into log of e with the base a. With the base, here it should be a. See it again. The derivative of log of x with the base a is equal to 1 upon x, log of e with the base a. It should be a here. Now again differentiating dy by dx by using this result, it can be written as 1 upon this log of, because this is our x, this is our whole x. So differentiating of it we are getting here. Dy by dx is 1 upon log of x with the base 5 into log of e with the base 5, using this result into the derivative of this function by using the chain rule, the derivative of log of x with the base 5. Again this whole term will be as it is, 1 upon log of x with the base 5, and again this can be written as, it can be written as 1 upon log of 5 with the base e, again by using this result. The another form of base changing result, log of a with the base b is equal to 1 upon log of b with the base a. Now using this result we can express like this. Now the derivative of this again by using this result, it is again 1 upon x log of e with the base 5. Now simplifying again, it can be written as 1 upon x, we are writing here. This term will remain as it is, again this term will remain as it is. Again log of e with the base 5 can be written as 1 upon log of 5 with the base e, so that these two terms are the same. Then simplifying, it is what, 1 upon x into, these are the two same terms, sorry, this is 1 upon x into 1 upon log of x with the base 5. Now these are two same terms, so this can be written as 1 upon log of 5 with the base e whole square. Now see the next question. Now the question is, we have to differentiate phi equal to 10 raised to power 3 log of x with the base 10. Now it can be written as y equal to log of x cube with the base 10. This 3 power can be written here by using the third law of logarithm. Now y equal to 10 log of x cube with the base 10. Now again here our variable is what? It is the power of what? 10. Now by taking log both sides with the base 10, taking log both sides with the base 10, it can be written as log of 5 with the base 10. Again it can be written as the whole log of this with the base 10. Now here left hand side remain as it is. It is again here we can write it here by log of x cube, log of this remain log of 10 as it is. Now this can be written as log of x cube with the into log of 10 with the base 10. See this point here, log of 10 as it is. Now here it is what, 10 raised to power log of x cube with the base 10. Now it can be written as x cube can be written as like this, log of 10 with the base 10. Now again this will be 1. So log of y with the base 10 equal to log of x cube with the base 10. Now cancelling the common term here, we are getting here out more, we can say simplifying, we are getting here y equal to x cube. Therefore its derivative is dy by dx equal to 3x here. Now we have to differentiate this whole function. Now here it is a logarithm of the product or the quotient of more than two functions. Now firstly we are using the laws of logarithm to separate all these functions. Now here y equal to, now we can write using the laws of logarithm. It can be written as log of e raised to power x plus 3 by 4 log of x plus 2 minus log of x minus 2. Because here is the product, so plus sign is here. Here is the quotient, log of m by n is equal to log of m minus log of n. Now again y, log and exponent, they are reciprocal function of each other, so they will cancel each other. We left with y equal to x plus this remain as it is. We can open the bracket if we want. 3 by 4 log of x plus 2 minus 3 by 4 log x minus 2. Again differentiating with respect to x. So therefore dy by dx, the derivative of x is 1. 3 by 4 as it is. Log of x plus 2 is 1 upon x. Our x is x plus 2. So it can be written as 1 upon x plus 2. Again 3 by 4 as it is. Log of x minus 2 is equal to 1 upon x minus 2. Again simplifying these two terms, 3 by 4 you can take it common here. Simplifying the remaining term, we are getting here minus 4 upon x square minus 4. Now again simplifying, we are getting dy by dx equal to x square minus 7 upon x square minus 4. See, this point is the main. Whenever we have a given the product or the quotient of two or more than two functions, we can easily separate by using the properties of logarithm. Then we can differentiate it. Now see the differentiation of implicit function. Any function of this form f(x, y) equal to 0, in which generally x and y cannot be separated. These type of functions are known as implicit function. If either x can be written in the terms of y or y can be written in the terms of x, then the function is said to be explicit function, that we have done in the previous question. Now the differentiation of implicit function. The question is find dy by dx when ax plus by is equal to cos y. Now in this function, if we want to separate x and y, it cannot be done. Now we have to find out dy by dx in here, differentiating with respect to x. Now we differentiate each term with respect to x. Now differentiation of ax. A as it is, the derivative of x is 1 plus b as it is, the derivative of y square is 2y into dy by dx, because we are differentiating y with respect to x. So we must put here differential coefficient dy by dx is equal to, again the derivative of cos y is minus sin y into dy by dx, because we are differentiating here y with respect to x. So must multiply by the differential coefficient dy by dx. Now this is the differentiation is completed. Now collecting the terms dy by dx of one side and another term on the right hand side, simplifying it, dy by dx equal to minus a upon 2by plus sin y. So this is what, how to differentiate the implicit function. Implicit function means x and y cannot be separated. If we have to find out dy by dx, we have to differentiate with respect to x. If we have to find out dx upon dy, then you have to differentiate with respect to y. It depends on the question. Either dy by dx has been asked or dx upon dy has been asked. Now again see the similar question. If sin y equal to x sin a plus y, find dy by dx. It is one of the important questions. We have to find out dy by dx. But when we are looking for the question, in this question we can separate x and y. So x can be written as x equal to sin y upon sin a plus y. Therefore this, sometimes we can call it, it is a form of explicit function, because x and y can be separated. So x can be written as x equal to sin y upon sin a plus y. But we have to find out dy by dx. Here in this question, we first find out dx upon dy. It means we are differentiating with respect to y, because the differentiation with respect to y is easy, because x is here in the terms of y. Differentiating with respect to y, dx upon dy. Again using the quotient rule here, it can be written as sin square a plus y. The derivative of sin y is cos y into sin a plus y minus sin y. Again the derivative of sin a plus y is what? Cos a plus y. Now we are doing the differentiating with respect to y. So therefore there is no need to introduce dy by dx, because we are doing the differentiation with respect to y. Now we have differentiating using what? The quotient rule. Now here see the very much important point here. Now here we can use here sin a cos b minus cos a sin b. See, this point is very much important. It can be written as sin a cos b minus cos a sin b. And we know that sin a cos b minus cos a sin b is equal to what? Sin a minus b. This is our a, this is our b. This can be written as sin a plus y minus a upon sin square a plus y as it is. Again simplifying, this is equal to sin y upon sin square a plus y. But here this is the value of what? Dx upon dy. But in the question we have to find out dy by dx. Then therefore if dx upon dy is sin y upon sin square a plus y. So therefore dy by dx is equal to sin square a plus y upon sin y, taking reciprocal on both sides. Now see the question of this type. If y equal to this, then prove that this. Again, this type of questions are very much important. Now y is given to this, we have to find out this. What we have to do? Simply we have to find out what? Dy by dx, put it in the equation. This equation must be satisfied. Now let us see how to do the question. Now y equal to sin inverse x upon under root 1 minus x square. Either we can differentiate by using what? The quotient rule. But I am doing like this. It can make my question easy. Transferring this term to this side, it can be written as y under root 1 minus x square equal to sin inverse x. It make our calculation work easy. Now differentiating again, with respect to x. Again differentiating with respect to x using the product rule. The derivative of under root 1 minus x square is equal to 1 by 2 under root 1 minus x square into derivative of this quantity minus 2x. Y as it is. Then the derivative of y is dy by dx. First function as it is. We have used here the product rule is equal to the derivative of what? Sin inverse x is equal to 1 upon under root 1 minus x square. Now taking LCM here, we have to simplify taking now under root 1 minus x square, taking LCM, it is become equal to minus xy plus dy by dx into under root 1 minus x square into under root 1 minus x square is equal to 1 minus x square is equal to 1. Either you can say by cross multiplication or by taking LCM under root 1 minus x square. Simplifying you are getting here minus xy plus dy by dx into 1 minus x square is equal to 1. Therefore, it can be written as 1 minus x square dy by dx minus xy equal to 1, that we have to prove. Now see the next question, the most important question of the differentiation of the implicit function. Now see here in this question, the equation is if x under root 1 plus y under root 1 plus x equal to 0 and x is not equal to y, then we have to prove that dy by dx equal to minus 1 upon 1 plus x whole square. This is the one of the important questions we did many times in the board exam as well as in the school exam. Now here see this. This is implicit function. This is what? Implicit function. X and y directly cannot be separated. Now here, but we have to prove that dy by dx equal to minus 1 upon x plus whole square. Now how to do this question? Given equation can be written as x under root 1 plus y, transferring this term on the another side. Now in this question, by somehow we should convert them into explicit function because our derivative has only the term x, it does not have the y term. Whenever we are differentiating the implicit function, in the answer you must have the term containing x as well as y. But if it is the explicit function, either the answer is the constant term and or the answer has only the term x. Now by looking this answer, we should guess, we have to convert them into explicit function, then we are getting this answer. We cannot directly differentiate it. Now the given equations can be written as by separating like this. Now here is the under root squaring both sides. Squaring both sides and transferring all the terms on the left hand side, x square plus x square y equal to y square plus y square x. Taking all this term to this side, it can be written as x square minus y square plus again xy common, we left with x minus y equal to 0. Now it is given that x is not equal to y. Taking here, making the factors x plus y into x minus y plus xy into x minus y equal to 0. Again x minus y is common, you can take it here. We left with x plus y equal to 0. Now in the question, this condition is given x is not equal to y. Therefore, x minus y cannot be equal to 0, because if x minus y is equal to 0, then x equal to y. But it is given in the question, x is not equal to y. Now the product of two factor is 0. Either each of them or both of them may be 0. But this cannot be equal to 0 according to the given condition. So we left with x plus y plus xy is equal to 0. Then simplifying, we are here getting y equal to minus x upon 1 plus x. So we have converted our implicit function into the explicit function, that is the requirement of our answer. Now here we can differentiate it by using the quotient rule. Minus as it is, applying here the quotient rule, the square of this, the derivative of first function, the derivative of x is 1 into 1 plus x minus x into the derivative of this function 1. The derivative of this is, the derivative 1 is 0, the derivative of x is 1. Again simplifying here, we are getting here dy by dx equal to 1 plus x minus x. Simplifying, we are getting dy by dx equal to minus 1 upon 1 plus x whole square. This is one of the important question, but I am going to tell you one more point here in this question. If here in the question we have to find out dy by dx, and it is constant or in the terms of x, it means we have to convert them into explicit function. If this quantity is not given, only we have to find out dy by dx. We can directly do the question. Just see the difference between the question and the given conditions. So now here derivative is in the terms of x. So we have to convert them into first explicit function, and then we have to differentiate it to get the required answer. Now let us see again this question. This type of questions are important here. Again, y equal to under root cos x plus under root cos x plus under root cos x up to infinity. Then we have to prove it here. Now again here it is here. Now the main point in this question we have to see here. Now the y equal to sum of all these positive terms. Y is equal to sum of all these positive terms, and these terms are infinite terms, and the sum of these infinite terms is equal to y. If I will take one term separate, then this can be written as y equal to under root cos x plus y, because we are given the infinite term. If I am deleting, we am separating one term, again the remaining term remain infinite. So this is the important point here. This can be written as y equal to under root cos x, this term we are separating, plus y, because the sum of all these infinite terms is equal to y. This is the most important point of this very question, how to start the question. See it here, it is equal to y equal to under root, first term will remain as it is, under root cos x plus y. Now squaring both sides, y square equal to cos x plus y. Again differentiating with respect to x. Again it is what? The derivative y square is 2y into dy by dx. The derivative of cos x is minus sin x plus dy by dx. Again collecting the term of dy by dx on the left hand side and simplifying, we get the answer here. To just complete this question, the main point is here how to start the question. This is a very much important point. When it is given y is equal to sum of all these infinite terms, if we can easily separate one term, the remaining again remain infinite. So this can be put again, it is equal to 1. Then scaling both sides, differentiating. Now again the derivative of this has x and y both. Therefore it is a differentiation of implicit function. Differentiating with respect to y, we get the answer. This is all about today. Today we consider some important question of the differentiation. Now we have to go through all the question and try the exercise question from the element of